we talked about area, and we did a lot of problems on area. We knew that we could integrate with respect to x and y and so on. It's going to be very, very similar for integrating with, for finding the volume. So we can integrate with respect to x and y and so on. Okay, but let's kind of do a, walk down memory lane and remember volume from geometry. Do you guys remember how we would find volume when we had two parallel bases, what the equation would be in geometry? Yeah, it ends up being the volume equals the area of the base times the height. Okay, so when we have two parallel bases, we do that. If it went to a single point, like a pyramid or a cone, it would be almost the same equation, but you would divide by 3, right? It'd be 1/3 area of the base times height. So in this case, it would be very simple. We would just have a pi r squared for the circular base, and then we'd have times h, and h is the distance that separates the two bases. So we'd have pi times 6 squared times 20. So our volume would end up being 720 pi, and we'd put inches cubed, so cubic inches. So volume always has some kind of units cubed. And obviously they got a little bit harder, so here's an example of a harder example from geometry. So when I used to teach geometry, these are the ones that the students always hated, because there's lots of steps. So basically if we have a pentagonal prism, so we have pentagons for the bases, and we would have to find the area of one of these triangles. And it ends up that there's going to be 5 of those triangles in there, right? So when we do that, we would have 54 degrees, and we'd have 4 along there, because really the whole thing was 8, right? And we'd have to find something we call the apothem, A. Okay, and we do this by doing tangent. So we'd say tangent of 54 degrees equals opposite over adjacent, so A over 4. And we'd multiply. This is like the one time that you would ever use degrees in calculus in an example like this. So we'd multiply over, and we get the apothem is like 5.056, I think. I can't remember what it was. Something like that. I guess I could do it quickly, but we'll skip it. So that would allow us to find one of these triangles. So its area then would be 1/2 base, which is the total length of 8, times height, which was that apothem. And that's going to be one of those triangles, but we need all 5 of them to make this whole base. Okay, so if we're doing volume equals area of the base times the height, what we found right now is B. Uh-huh.
For the A, I got
5.056, is that what I had?
5.506.
5.506.
Yeah.
Oh, that's funny. I wrote it right on the next part, but I didn't write it right here. 5.506, like that?
Yes.
All right. I was just memorizing that. I didn't actually put that in my calculator. All right. So here we go. So that's our B. And then H ends up being the distance between the two bases, which is 12. Okay. So when we find that, I wrote this number down, so I didn't have to do it again. I have 1,321.327, and our units would be cubic feet then. Okay. So I'm guessing that you feel pretty comfortable with that. It's been several years since you've been in geometry, I'm guessing, right? And I'm guessing that those might have been hard then, but they would be very easy right now. You're like, please give me those types of volume. Okay, and these volume problems that we're going to do are kind of similar, but it involves integration, of course, right? So if you look at these pictures, the pictures that we had before, if I chop in certain areas, I can get a common cross section. Okay, so if I take like an axe and I'm chopping, right? What kinds of cross sections do I have? What are those?
Circles.
They're circles, right? And if I chop on this one, what do I get? Pentagons. But they're all the same shape, right? So this formula, the volume equals the area of the base times the height, is actually a calculus formula. Okay, because it's kind of similar to taking a Riemann sum and saying, oh, well, I have all of these circles that have the same area, and I'm going to multiply by the distance that they fill, this height, okay? So that's what we're going to do here. So it says when we do not have cylinders or prisms, we can still find the volume with a method similar to a Riemann sum. Okay, but all of those shapes that we're cutting have to be the same shape. They're all going to be circles in this section. Okay, so we cut our shape into S pieces called cross sections, kind of like a loaf of bread. So we're doing chop, 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 chop. And if I had a piece of bread, that piece of bread has a volume, right? It's not an area, it's a volume. There's a certain thickness to the bread. Okay, but remember what we did when we did areas with rectangles? We took our rectangle and we made it a certain width, and then we made it smaller and smaller and smaller and smaller and smaller until it was infinitely thin. And that kind of blew your mind because you're like, wait, it's infinitely thin. How can there be an area? How is this going to fill this space? Do you guys remember that? Same thing with volume. So we are cutting our pieces so that they are no longer like a thick piece of bread. They now are infinitely thin. It's just going to be like a little flat surface, okay? And we're going to call these slices discs because they're all going to be circles. So it's going to look like a CD kind of, but no hole in it. So they're going to be discs. So once you find the volume, air quotes, volume of each disc, we add all the volumes together, okay? So this works even if we have an infinitely thin disc. We can still get the volume. So a common formula in calculus is that the volume is equal to the integral of the area. And some of you guys have noticed this with common formulas from geometry. So do you guys remember a sphere? Do you guys know the volume of a sphere? 4/3 pi r cubed. Do you guys know the surface area of the sphere? Yeah, it's derivative, right? They're related in that way. Does that make sense? So a lot of volume and area formulas are related in that way. Okay, so here's your formulas. You have the picture. The picture probably doesn't make much sense. We're going to do lots of examples. This rectangle is really more like a line. So if I just have an infinitely thin rectangle, and I start rotating it around the x-axis, when I do that, I create a little circular shape. Okay, I know it doesn't look like a circle. Think 3 dimensions. So again, if I have a line here and I rotate around the y-axis, I end up getting a circular shape. And that circle has an area. The area of that circle is pi r squared. So what we're going to do to find the volume is we're going to integrate it. So that's what all of this is saying. Okay? So we can integrate with respect to x, or we can integrate with respect to y. So the x one is when your circles, your cross sections are up and down, like you have circles that are up and down, because you're making chops this way. Like if I'm taking the axe, or I always use the term guillotine, which is kind of morbid, but if I take a guillotine and I'm chopping this way, this way, this way, this way, this way, the thing that's changing is my hand is moving. My hand is moving from the left to the right. Does that make sense? So x changes. Okay, but if I do my chops this way, do you guys see that the y is changing? Okay, so that's when you integrate with respect to y. So the dy literally means change in x, change in y. Okay, so dx, dy. Okay, so it's not that complicated. Let's do some examples. All right, so find the volume of the solid obtained by rotating about the x-axis, the region under the curve. Y equals the square root of x, so we still draw a picture, from 0 to 1. Okay, so we still kind of, you know, just like we did in our area, we kind of do a little shaded region. But now we're going to take that, you know, piece of paper or whatever it is, this infinitely thin thing, and we're going to rotate it. And we're rotating around the x-axis. So as I take this like flat surface and I'm rotating it around and around and around and around, it's creating a certain shape. Can you guys kind of visualize what shape this is? If you can't draw it, it's fine. Like many of you guys are drawing impaired. I get it. It's what? A what?
Semicircle.
Semicircle? Kind of like a semicircle, but it's 3 dimensions. It's like a hemisphere, maybe? Kind of like a hemisphere. I don't know what you'd call it. The bottom of an acorn? I don't know. I said it kind of looks like a headlight, but a headlight's kind of curved on the front. I don't know. Do you guys see the shape? It's like a little bowl type thing with, it's 3 dimensions. And your cross sections are all circles.
Like a lemon. Yeah.
Like part of a lemon, kind of. Yeah, I could see that. Good. All right, so we get these cross sections that are circles. So we have a whole bunch of circles, an infinite number of circles there. And these circles all have a certain area. Okay, but in order to find that area of a circle, we need its radius. So draw on this little line, and we're going to call it r. So we're going to find the radius. So r depends on where x is located. Okay, so if I was at the very beginning, right here at 0, my radius is nothing. I don't have a radius, right? But if I'm at r equals 1, or if I'm at, not r equals 1, x equals 1, what's my radius then? 1. So it's changing between 0 and 1. Okay, and it depends on where your x is. What's the equation for r? Any guesses? It's the square root of x. It's just the height of that curve, right? So if I was at 1/2, then my height there would be the square root of 1/2, root 2 over 2. Do you guys see what I'm saying? Okay. So that's going to be our r. So when we set up our equation, we're always integrating the area. We're going from x equals 0 to x equals 1. But our area ends up being a circle, pi r squared. You don't usually have to write out all of this stuff. I'm just kind of writing it for your notes. So what you can do is you can do 0 to 1. We're going to put the pi out front, and we're going to have our r, which is square root of x, squared. So it works out to be pi out front, 0 to 1, x dx. Very easy to do without a calculator. So we have the pi. We're going to have a 1/2 x squared going from 0 to 1, which is going to be, I'll just put the pi over 2 out front, and I'm going to have 1 squared minus 0 squared, which gives me a final result of pi over 2. Okay, so we're always setting it up with pi r squared integrated. So let's look at another sketch. So it says, find the volume of the solid obtained by rotating about the x-axis, the region bounded by the lines. Y equals 2 minus 1/2 x. Okay, so we know what that looks like. The y-intercept's 2. The slope is negative 1/2. Oh, missed it. All right, and we're trapped by y equals 0, which is the x-axis, x equals 1, and x equals 2. So those are all my lines. So I end up being this little tiny area, which I'm shading in red for you. Okay, and we're rotating around the x-axis. So can you guys kind of see in your head what kind of shape you're getting? It's hard for people to visualize this sometimes. It's kind of like a trapezoid, but it's got circular cross sections. So it's like this shape, it's just on its side. Like a lampshade, kind of. I thought it looked like a dog bowl, kind of just a solid dog bowl, or like the thing you put around dogs, their collar, the cone. Yeah, do you guys know what this is called? I can't say it. It's called a frustrum. I have the worst time saying that. You could also call it a truncated cone. It's a cone that's been chopped off, right? Do you see it? All right, so this is our shape. And so we want to come up with what r is. So for any location in there, what is r? So r is going to be, what's the height that I'm using? What's the top line, basically? The 2 minus 1/2 x. Does that make sense? So no matter where you are, between 1 and 2, that's going to be your radius, your height. Just like area, top minus bottom. The bottom line is your y equals 0, your x-axis. All right, so our volume, we're going to go from 0 to 1. We're going to put a pi out front. You can put it inside too, it doesn't matter. And then we have r squared, so 2 minus 1/2 x squared. Oh, what did I do? Oh man, 1 to 2, who got me? Audrey got me. All right. All right, so we get that. And you could FOIL that out pretty easily. You could find what the answer is. I went ahead and found it for you. So it's going to be 19 pi over 2, or 19 pi over 12. Okay, and I always like the most precise answer. I like the fraction with the pi. Okay, that is the most precise possible. I have not rounded at all. But if you were going to round, here are the other two answers you could have. You could do 1.583, which is 19 over 12 pi, or you could do 4.974. I think that's a 7. Can't read my own handwriting. Which would be pi times the 1.583. Does that make sense? So you can write any of those, and the AP test will accept all three answers. This is the one I like, though. Make your teacher happy when I grade things. I don't want to look at all your different forms. Let's just be consistent, and I'll do it the same way. It's not just a dream of a teacher, because they're like, I'm not going to do it that way. All right, number 3. So this picture is kind of right. I stole this from the internet. but these numbers are not right over here, so cross those out because it really should be starting at 0. All right, so determine the volume of the solid obtained by rotating the region bounded by y equals x squared minus 4x plus 5 between x equals 1 and x equals 4. So we have the picture. So we had a parabola, right? That was the y equals x squared thing. Y equals x squared minus 4x plus 5. And we're going from x equals 1 to x equals 4. So we get that region under the curve. So if I want to come up with my radius, right, I start from my axis of rotation, I start from the x-axis, and I go up to that top curve. So what distance is that radius? What do I write for it? You guys are awful quiet. It's not a hard question. X squared minus 4x plus 5, right? Does that make sense? Now, as long as you've written r somewhere, really, to get all your points on the AP test, here's what you do. You just do pi, the integral from 1 to 4, and then you would just do r squared dx. And you would get full points for your setup. Okay, usually they're very nice grading these. You get lots of points for volume and area and volume. You get a point for your pi, you get a point for the 1 to 4, you get a point for the correct r, which you had written here. Does that make sense? And then you get a point for your correct answer. So I'll go ahead and, for the sake of your notes, I'll write it out. So I'll just say x squared minus 4x plus 5. The thing that people forget, though, is they always forget that squared. And they might put it into their calculator, but they forget it originally. Okay, and I went ahead and found this number too. So it's 78 pi over 5. Okay, so you guys can check with Math 9 later if you want. All right, still feeling pretty good about this? Okay. So this is usually the part of the lesson where someone says, is it always that just the function? Is it always like r is always just whatever f of x was? No, it's not.
Just what f(x) is?
No, it's not. So we're going to have some harder examples. All right, so it says sometimes we do not have discs. Instead, we have what we call washers. Okay, do you guys know what a washer is?
It's a donut but made of metal.
Yeah, kind of. It's a donut made of metal. So if you've used tools before, hopefully you all have at this point in your life.
Yeah,
You're like, no, never. It's the little piece of metal that goes between like a screw and a surface. So we'll put like a little flat silver piece that has a hole in it. You guys all know what that looks like? Okay, so it's kind of like a disc, but it has a hole in it. All right, so it says in order to solve these problems, we will take the outer volume and subtract out the inner volume. So we're going to use something I call an outer radius and an inner radius. Okay, so the outer volume is going to involve pi capital R squared, and the inner volume is going to involve pi little r squared. Okay, so example 1 is the one I messed up on. I drew the wrong shaded region. Oh, kicking myself. All right, so number 1, so find the volume of the solid obtained by rotating the region bounded by y equals x squared from 0 to 2. Okay, so just like the area problems, it should be right here. Okay. And now we're going to rotate around the y-axis. So if we're rotating around the y-axis, this is a vertical axis. This is different than what we've done. We want to use y's. So everything is going to be y's, just like when we switched things with area and did dy, right? So we're going to have a dy, we're going to have our limits of integration, our y values. We're going to have everything in there as like x equals a bunch of stuff with y, right? We need to change everything to y's. So what's this point, first of all? It's 2 comma 4, right? Because it's y equals x squared. So we're going to set it up. So we're going to have our volume equals pi, and we're going to go from y equals 0 to y equals 4. Right? These are y's. But it's a little bit tricky. Can you guys visualize what the picture is? It's a little hard. That's not drawn very well, but you kind of get it. All right, let me scoot that up a little bit. It's looking like this. Do you guys kind of understand this picture? So on the outside, there's a certain shape. What's the outside shape? a cylinder, right? Do you guys see it? It's the outside shape is a cylinder. And then what's the thing that we're scooping out of the inside? Like a bowl. Do you guys see it? So we have a cylinder, and then we're taking out the bowl on the inside. So really what this is it's two different volume problems. You're taking the cylinder volume problem, and then you're subtracting out the bowl volume problem. So the way that we do this is we put it all together, and we do pi r squared minus little r squared. And then it's all in terms of y. So we need to figure out what our capital R and our little r are. I always feel like a pirate. R. Okay. So when we do our capital R, R goes all the way to the outside of the region. So capital R goes all the way there. And it's going to be in terms of y. Can you guys see what that distance is? It's a constant number. It's just a number.
2.
It's just 2. Do you guys see? It's always 2 for the outside there. Okay, and it's because of do you guys remember the area problems when we did right minus left? That's why it is. It's the line 2 minus 0, right? So 2 minus 0 is 2. Maybe I'll write that. 2 minus 0 equals 2. All right, and then our inner radius. It is not. It's only 2 once you get to the very top. It changes depending on where y is located. So our equation was y equals x squared. If I solve for x, it's going to be x equals plus or minus the square root of y. So this side of the curve is negative square root of y, and this side of the curve is x equals positive square root of y. So what's the distance, little r? Square root of y, right? Square root of y minus 0, square root of y. So we're good. So we're going to set it up. We have pi, 0 to 4. We have 2 squared minus square root of y squared dy. So we get an answer. I don't know if I actually found it. Let me see. I'll just go and put this into Math 9 real quick just in case. So I'm going to have 4 minus y. Yeah, we get 8 pi. Okay, so these can get tricky. So when you have the outer radius and the inner radius, you always should draw a picture. And you should draw your outer radius starting from your axis of rotation going to the outside, inner radius starting from the axis of rotation going to the inside. So we're going to do lots of practice problems. All right, the next one. So it says the region R enclosed by the curves y equals x and y equals x squared. So our region enclosed is right here. Is rotated around the x-axis. Okay, can you guys think about what shape you're getting as we're whipping that around really fast? I always make a sound effect. I always go shoo, 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 shoo. So I'm whipping it around very fast. What's my outside shape? You guys always just wait on me to draw it, don't you? It's a cone, right? The outside shape's a cone. What's the inside shape? I don't know. Like the end of a trumpet, maybe? I don't know. What do you call that? What shape is that? I have no idea. Like a funnel? Okay. So if we come up with our outer curve and our inner curve, let me kind of zoom in. So let me draw it again. Actually, maybe that's not a good drawing. Okay, so our outer radius starts from our axis of rotation, the x-axis, and it goes all the way to the outside of the shaded region. Okay, what line was this? This was y equals x, right? That's what your outer radius is. R is equal to x. Your inner radius goes from your axis of rotation to the inside part of the shaded portion. So what line was that? That was the line y equals x squared. So what's my inner radius? X squared. Does that make sense? So outer radius is x, inner radius is x squared. Oops, I tried to erase that. So when we set this up, our volume is going to go from x value to x value. Do you guys know the intersection point? The first one's 0, 0. That's easy. What's the one over here? When you set x equal to x squared? Yeah, it's 1. So we get 1, 1. So we're going from x equals 0 to x equals 1. Grab my little pi. I'm going to put my pi out there. And I have my outer radius squared minus my inner radius squared. And now I'm integrating with respect to x. So I have 0 to 1. I'm going to do x is being squared, and then x squared is being squared. So this one would actually be pretty easy to do by hand. I'm going to go ahead and do it quickly by hand. So I'm going to have x cubed, oh, hang on. I'm going to have x squared minus x to the 4th, which when I integrate, I get 1/3 x cubed minus 1/5 x to the 5th. And I'm going from 0 to 1. So you end up getting pi on the outside, and you have 1/3 minus 1/5, which gives you 2 pi over 15. Okay, you got it? All right. So let's try another one. So we need to think about the outer radius, inner radius. So now it says find the volume of the solid obtained by rotating the region R from example number 1 around y equals -2. So these are the ones that I had trouble with when I was in school. Okay, so the region from number 1 was bounded by y equals x squared. And we were going from x equals 0 to x equals 2. So we have this little region right here. And we were rotating it around, so now we're rotating around the line y equals -2, which is a horizontal line. Okay, so these are tricky problems. Okay, the axis of rotation is not the x-axis or the y-axis. Our outer radius is going to be a little bit more difficult. Okay, so I want you to think about that shaded region. And when you draw your outer radius in, you go from your axis of rotation all the way to the outside part. And your inner radius, you go from the axis of rotation all the way to the inside part. Okay, and it's just like area. If I want to find the distance from here down to this line, and I was doing area, do you guys remember how we did that? We did top minus the bottom. What's the top curve? What's the bottom curve? So the top curve is x squared minus the bottom was -2. You end up getting x squared plus 2. Now think about why that makes sense, x squared plus 2. Just this, let me try to draw it another color. Just this distance right here was x squared. Do you guys agree? Right, if I started on the x-axis, it would have just been x squared. Where did I get the plus 2? I went 2 units further down. So it's 2 units longer. Do you guys see that? So as long as you're doing top minus bottom, you're going to get the right answer. Don't worry about it. All right, what about the inner radius? What's that distance? It's going to be 2, right? It's going to be 0 minus a -2. So we end up getting 2, top minus bottom. The line 0 minus -2. It's a really weird shape. It ends up, yeah, it's like totally like the end of a trumpet kind of. Because you're going to have that straight line, and then you're going to have something here. And it's going to look like that. Do you guys see it? It helps that I was an art major too, doesn't it? See, your calc teacher could have no idea how to draw this, and you'd just be like, what? What's going on? All right, here we go. So we're going to have pi goes from our x values of 0 to 2. My outer radius is going to be squared minus the inner radius squared. And as long as I write that, I'm good. So I get all my points for my setup. So I'm going to have x squared plus 2 squared minus 2 squared dx. All right, and I think I found that. Don't know where it is. All right. Oh, maybe I didn't. Darn. All right, so I gotta find it. So math 9. X squared plus 2 squared. Don't forget your squareds. That's the big thing. $256 pi over 15 is the answer. Okay, so let's kind of recap. So when I had a horizontal axis of rotation, do you guys see how that was a horizontal one? Right, y equals -2. I always think it looks like which axis? It looks like the x-axis, therefore it's dx. Okay, that's the way you're going to keep track. So horizontal looks like x-axis, I do dx. Vertical looks like the y-axis, I do dy. Okay, remember if you're integrating with respect to y, you need everything in terms of y. So you need to solve your equations for x. X equals a bunch of stuff with y. You need to go from y to y. Okay? Does this all make sense? Are you guys understanding so far? You understand now, and then you get to your homework and you're like, meh. So I'm going to give you guys a couple days to your homework. All right, so number 1. So it says find the volume of the solid obtained by rotating the region bounded by the line y equals x and y equals the square root of x about the line x equals 1. Okay? So we don't have around the x-axis or y-axis. We have around a vertical axis, though. So it's like the y-axis. So we use y's. So we're going to integrate with respect to y. So really we should solve both these equations. Well, that's just x equals y. That was easy. What about this next one? X equals y squared, yep. And our y values go from 0 to 1. That was the intersection point, 1, 1. And here's our shaded region. It always helps to kind of shade because when you think about the outer and inner radius, you go to the inside of the shading, outside of the shading. So from my axis of rotation, I'm going to go to the outside of the shading. That's going to be capital R. So capital R, how do I find it? It's a distance. If I find the distance between any 2 points that are sideways like that, I do the right minus the left, right? That's what I'm doing here, just like area. So I'm doing right minus left. Actually, if you did left minus right, it would be okay because you're going to square it anyway. But let's do it the correct way. Right minus left, so I'm going to have 1 minus. The left side is the line y equals square root of x, which is x equals y squared. So it's going to be 1 minus y squared. And then our inner radius goes from our axis of rotation to the inside of the shading. So it's going to be 1 minus just y. Does that make sense? So your volume is going to be from y value 0 to 1. Remember, these are y's. Everybody always messes that up. Capital R squared minus little r squared, dy. So you can write all of that. You can say it's 1 minus y squared minus 1 minus y squared, or you can just leave that part off because you've already written what r and r are. So we're good. Okay, so I think your answer ends up being pi over 5. I tried to put these in before class so I didn't have to do all the Math 9 clicking. Okay, still feeling good about these? Okay. All right, number 2, find the volume of the solid obtained by rotating about the y-axis. So now we're going around the y-axis. So we have y equals the cube root of x. That looks like this. And y equals x over 4, which is going to be kind of it's a line, but it's kind of a shallow line, not very steep. And we're just doing the region in the first quadrant. Now, if you did the region in both of the quadrants, you'd just double what you had, right? You'd find the first quadrant one and double. Because when you go around the y-axis, you guys see how it would create like a, I don't know what the shape would be. Be like something like this, and then something on the bottom too. But they'd be the same thing. Does that make sense? Okay. So this point right here is, well, I don't know what that point is. We got to find it. So you can find it by using your calculator if you want to. Or you could set the two equal to each other and solve. I think it's 8, too. Does that work? Yeah. If I plug in 8 for x, I get 2 for y for both of them. Yeah, I think it's 8, too. So you could find that on your calculator if you want to, if you weren't sure. Okay, so if we're rotating around the y-axis, we're going to integrate with respect to the y. So when I set it up, I'm going to have pi, and then I'm going to put a dy at the end. My y values go from 0 to 2. And I need to come up with my outer radius and inner radius. So my axis of rotation is the y-axis. So here's where my outer is going to be. Think about the right side minus the left side. The right side was this line y equals x over 4. How do I rewrite that? X equals 4y, right? So we're going to have 4y minus 0 is our capital R. So just 4y. Oh, wait, am I going? Yeah, I'm going around the y-axis, okay. And then my little r goes from the inside. So from that axis of rotation to the inside of the shading, or the first part of the shading. So what's that going to be? You got to change it, right? X equals y cubed. So you're going to have 4y squared minus y cubed squared. So you can simplify that out. It wouldn't be hard to do by hand at all. You get the lovely 512 pi over 21. Didn't I have that number before? Maybe I wrote the wrong number earlier. Oh. So yeah, that one's still good. All right. And then the very last one, I'm just going to show you the setup real quick. Okay, so your setup is if you have, I would probably just graph this on your calculator. So it's going to be shifted right 1, and it's going to look like a square root function. The other one goes like that, but you're going around x equals -1. So when you do your outer radius and your inner radius, again, it's a y one, right? We're integrating with respect to y. So your outer radius ends up being, I can't do it as fast as I wanted to. It's going to be y plus 1 plus, because you're going to have a minus a -1. Do you guys see where that minus a -1 is coming from? Because it was this side. It was minus a -1. So you get y plus 2. And then your inner radius is going to be y over 2 squared plus 1. So it's going to be y squared over 4 plus 1 minus a -1. So you're going to get y squared over 4 plus 2. And when you find the answer, you should get 96 pi over 5. So you would do all of your, like you'd say 0 to whatever this intersection point is. Can't remember what it is. And you should get 96 pi over 5. So you might try that on your own. All right, let me pass out your homework.